Okay, so number 17, we first have to graph this. So we have a vertical asymptote x equals 0. They're not wanting us to look beyond that anyway. Horizontal asymptote y equals 1/6 because the degree was the same in the top and the bottom. So we have to look at the coefficients. Lead coefficient here is a 1, there it's a 6, so 1/6. So it technically doesn't get all the way down to 0 anyway. And then for some points, you can plug in maybe 1 and 2. 1 gives us 1.167, 2 gives us 0.67. And so when I only look at the first quadrant, there's what my graph looks like. Part B, so here they're saying plug in 4 for x. So 6 plus 4 is my numerator, 6 times 4 is my denominator. So that's 10 over 24, which is 5/12. So that's the portion that they get done. You could convert that to a decimal or a percent if you'd like, but you can leave it just like that. What about the domain and value? So the domain, x can't be 0, and x is the number of hours her dad is working. So he can't. We're not going backwards. He can't work negative hours. So there's a reason our domain is really just x is greater than 0. Dad can't work negative hours. The range, we're talking y. That's the portion of the job. So they can't do a negative job either. It must be positive. Doesn't make sense for it to be negative. So pretty short, concise answers here because I don't want to write very much. But if you look at my hard copy, I have a lot longer answer and explanation written there. Question number 18. So when we add in the 183 hits to his 2,067, he's now got 2,250. For at-bats, he had 67, and now he's added in x at-bats. So there's our equation. Vertical asymptote then would have to be at negative 67. Horizontal asymptote, the degree of the denominator is larger, so that means it's y equals 0. See, what is the meaning of the horizontal asymptote, the 0? So it means his average, because that's what it's measuring, is average. So the average cannot be 0. He's guaranteed to have an average higher than 0. Number 19, y varies inversely as x. Plug your numbers in. Y is 5. X is 5. We see the k is 25. So now that means my equation, when I plug 25 in there, is this. Now find y when x is 45. We can divide them both by 5, giving me 509. Number 6, y varies jointly as x and z. So y is 6, when x is 4, and z is 12. It's 48. Divide by 48, k is equal to 6 over 48. That will simplify to 1/8. So k is 1/8. So my equation, y equals 1/8 times x times z. So find y when x is 24 and z is 5. 1/8 of 24 is 3 times 5 is 15. So y equals 15. All right. Weekly sales. I'm going to go ahead and refer to that as S. Money spent on advertising, I'm going to call that A. It varies directly, so I'm going to say S equals K times A. Last week's sales, 10,000. Advertising, 2,000. So divide by 2, I see that K has to be 5. So my equation now is S equals 5A. So what should the sales be? In a week that we spend $1,200 on advertising. So 1,200 times 5 is 6,000. That should be, our sales should be $6,000. And lastly, distance. I'll call that D. A car can travel in a certain amount of fuel, varies inversely with its speed. So speed I'll call S. With a certain amount of fuel, notice that in both cases they have the same amount of fuel. So that doesn't really become a factor or a variable in the problem. So we can kind of disregard the 10 gallons. They're both comparing the same thing. So keep that in mind. That's just saying that we're dealing with the same situation. So distance varies inversely with speed. So 50 miles an hour, 336 miles. So we can multiply by 50, and I see that K is 16,800. So now I know my equation. Distance is equal to 16,800 divided by speed, as long as we're using 10 gallons. So second situation, how far, what would the distance be if we go 60 miles an hour? So we'll take 16,800 divided by 60 for 60 miles an hour, and we get that the distance would get 280 miles. So that's how far they would go in that case.